Welcome to the video on ions. We have discussed up till now neutral atoms, meaning that their number of electrons is equal to the number of protons. So a neutral atom for arsenic would have 33 electrons, 33 protons. However, we talked about this last unit, in Unit 4, we talked about how all the elements want to be like noble gases, or as close to noble gases as they can possibly get. And so they're going to gain or lose electrons to get to that point. So how many they're going to gain or going to lose, let's talk about where those electrons are. We know that sulfur wants to become like argon, and we know that it's going to gain 2 electrons to get there. It's got a -2 charge. Where are we going to put those 2 electrons? Well, once you see the orbital diagram, it becomes very obvious where we're going to put those 2
Kim Lowe,
electrons.
please come to the main office. Kim Lowe to the main office.
We got 2 spots left, one here and one there. Or the noble gas notation, and put it here and there. Once we do that, this becomes isoelectronic to argon, meaning it has the exact same electron configuration as argon. Iso means same, electron configuration. So when we do that, now we have sulfur, the ion. So we also could have sulfur, the ion over here, as far as the electron configuration is concerned, so neon. And now we have 6 in our 3p as opposed to just 4. So that's how we do ions. These guys gained electrons. Let's talk about losing electrons. First of all, let's discuss the possibility of losing electrons when you are magnesium. So I'm going to move this up a little bit, some space here. If we have magnesium, that is the noble gas neon plus 3s 2. Terrible error. Or we say neon, or the electron configuration 3s 2. All right, so how does this thing get to become like a noble gas? Well, it's got to lose those 2 electrons. Then it'll be the noble gas neon. So it's going to lose those 2. We'll just get rid of those. And now magnesium has the same electron configuration as neon, and so because it lost 2 negatives, it becomes positive. Magnesium, +2. So that's how anions gain their electrons and cations lose the electrons. You can see exactly which electrons are going to lose. What about molybdenum? What's it going to lose? Molybdenum has a lot of options, and that's what happens when you have transition metals. They can have multiple options of losing. They always lose. But they can lose different numbers of electrons depending on what they're trying to do. Remember in the last video we talked about how the valence electrons are actually the ones in the s because they are in the outermost energy level. 5s is farther out than 4d. So when this loses, it'll start losing out of here. So it'll start with these electrons. If it loses 1, it'll lose that one. If it loses 2, it'll lose those 2. If it loses more than that, then it'll drop down. Now it's 4d's in the outermost. Those are its valence electrons now. And so it can start losing from here. So molybdenum can have several charges. For example, it could be molybdenum +2 if it just loses those 2. It could be molybdenum +3 if it loses that one. We could go all the way up to molybdenum +6, meaning that it lost those 2 and those 4. And so and then it would be down to just the element krypton. Now, why doesn't it do 6 all the time? Well, because losing 6 electrons is a lot. That makes you kind of unstable. So it doesn't always lose 6. Sometimes it'll lose partway to 6. But that is something that all the transition metals will do, with the possible exception of these 3, silver, cadmium, and zinc. They always lose that number. So, for example, zinc always loses its 2. Meaning it loses its 2 4s electrons. And cadmium always loses its 2 5s electrons. Silver does interesting things which you don't need to know about why it does that, but it is actually going to lose 1 at a time. And so that's how you make ions out of elements. So when you do your online homework, read very carefully to make sure whether it's talking about the base element, the neutral element, and the atom, and then you just do the electron configuration according to the periodic table. Or if it's an element, you're going to need to either move up on the periodic table for an anion or move back on the periodic table for a cation. So for sulfur, it's a -2 anion, so we're going to move up 1, 2 to argon. For aluminum, it's a +3. +3. So that means we're going to move back 3, 1, 2, 3, and be the noble gas neon. So we're going to lose those 3 electrons. So just watch out where you're moving up and down on the periodic table to figure out what your electron configuration is going to be for ions. Thank you.